Okay, so you may have heard of character AI. It's become a very popular sort of chat interface. And rather than be like ChatGPT, it's all about characters. And now it's been out for over a year or so. It's quite a famous company in the terms of LLMs because the two founders of it, one of them is Noam Shazeer, and the other person is Daniel de Freitas. So Daniel de Freitas was one of the key people behind some of the early language models for chatbots at Google. And Noam Shazeer is very much a legend when it comes to LLMs, having been one of the key authors on the famous Transformer paper, Attention is All You Need. And for a long time was at Google working on some of these ideas. He's one of the key people behind the LaMDA paper, the LaMDA 2 model, etc. Noam's thing was always about scale. So just to give you a very quick personal anecdote, when I first met Noam was over 5 years ago, and GPT-2 was out. And if you remember at the time, everyone at OpenAI was saying that, GPT-2 was so dangerous because it was this 1.5 billion parameter model. And Noam quite cheekily just pulled out this demo of running a 5 billion parameter language model at the time, which back then was huge. Obviously, it would be considered almost like a small language model by today's standards. But back then it was huge. And when I asked him, like, wow, like you've got this really big model, he proceeded to chuckle a bit and say, oh, you think that's big? And then not too long after that, they went on to make much bigger models. I think a year or so later, they ended up releasing the Switch Transformer, which was a trillion parameter model. It's still actually the biggest open source model that I know of to date. Maybe there are one or two from China that could be bigger, but I'm not sure if they've been fully put out. But anyway, Noam was always very interested in this sort of conversational thing. And along with his co-founder, they left to form Character AI. Now, Character AI has become extremely popular for people chatting with characters. And then recently, they've started to put out some interesting articles and blog posts around things to do with inference, around doing this kind of thing. Now, doesn't surprise me at all. Coming from Noam and the team there, they're very pro-research. I think in the past, they were very pro-open research. So we can see that they are actually sharing things. And this video, what I wanted to do was take a look at a new mini kind of framework that they've put out for basically dealing with prompts. So you could imagine that at Character AI, they have a lot of prompts in there because they have a lot of characters in there, clearly. You can see the characters vary a whole bunch. I was one of the beta users for this, and I actually made the Marcus Aurelius chatbot, testing it out just for myself. It's crazy to see that people have chatted to it nearly 200,000 times. There's a whole bunch in here that have way more than that. When you look at some of the different characters in there of psychologist, of Elon Musk, etc. in here. So clearly to manage all those interactions, they need to be able to deal with prompts very well. They need to be able to capture good system prompts and stuff like that, but also be able to inject things into a conversation. And then people have conversations with these bots for hours a day. And you could imagine that obviously you can't fit all of that into the context window. So you need to work out how you're going to truncate and stuff like that. Now, frameworks out there like LangChain, etc., have some ways of doing this. But it's really interesting to see that Character AI has actually published their own one of how they're doing this and made it totally available for people to be able to use. So in the blog post, they talk about prompt being a function of state and how people are basically using F strings and these sort of wrappers around prompts to do this. So one of my key issues with many of the frameworks out there has always been, how do you basically look at the prompts, change the prompts easily? And a lot of the frameworks don't make this as easy as I feel it should be a lot of the time. So it's interesting to see that Character AI has put out their own framework, which allows you to be able to use sort of a combination of sort of F strings with YAML files and this sort of Ginger 2 templating to be able to load and render prompts as you need them, and to be able to easily inject information into those, which you can then convert to the OpenAI standard, or what's become like the ML chat standard way of showing these messages now, with a role being user, role being system, role being assistant. and being able to go back and forth in these kind of things. So that's a format that's pretty much been adopted by everyone now. So what this framework allows you to do is to basically easily inject things into that format and to be able to do some things like truncation, to keep things under a certain size for your context window, etc. So I've put together a notebook just going through some of the examples of this. It can work with LangChain, with OpenAI out of the box, pretty much most of the models that are supporting this sort of ML chat interface. So let's go through it and have a look at how it actually all works. Okay, so first thing you want to do is basically install the prompt poet. I'm going to be using OpenAI for language modeling here. So I'm also installing the LangChain OpenAI in here and just setting up the key, etc. So the main thing to understand, and I'm guessing most of this already, is that like in Python, you basically have F strings where you can basically substitute a variable in a string for something else. So in this case, you can see I've basically just put the variable equals Sam. Hello, my name is variable. And then it just creates the string, hello, my name is Sam. And this is what the core concept of all of this is, right? You've got templates in this case where you can basically substitute out something, and then that template is going to be converted into a particular format. Now that format is going to be the ML chat format. So you can see here we've got that we're going to have some system instructions. Your name is character name. We're going to have a username. We're going to have a user query. We're going to have a character name again. So you can see that for the template data, a character name is going to be character assistant. A username is going to be Jeff. User query is, can you help me with my homework? So when we basically take this, we're taking this raw template and this template data, and we're putting them in to assemble the prompt. So when we run that, nothing will happen straight away, but you'll see that if we look at the output now, it's converted it to this, where we've basically got this role system. Your name is character assistant. You are meant to be helpful, never harmful to humans. Jeff, can you help me with my homework? And then character assistant. So if we run that through LangChain, because of this format, we can actually run it, straight through LangChain. This is made for going into the OpenAI style format and LangChain kind of format in here. So you can see that when we run that through, we set up a model, chat OpenAI 84.0 mini here. We just invoke it, passing in these prompt messages. It can respond back, of course, Jeff, what subject are we working on? What do you need help with? Then, of course, we can append this to something, right? To a sort of message list. So we can look at that as we go through. Now, that will work with LangChain. It will also work with just straight up OpenAI. So you see, if we just call OpenAI directly and we pass in the prompt messages, this system of having sort of a list of messages where each one has a role either system, user, or assistant, and then we will get, one back in here. Now, you may find I think this is getting less and less, but there were certain models that wouldn't let you have like two users in a row or two systems in a row, or it wouldn't let you have system and stuff like that. So those ones you will need to play around with this a little bit. But it does seem that the character AI people are actually going for this kind of system for their own models. Now, they're not using, I'm almost certain they're not using OpenAI. They've got their own models in there. But they've obviously decided to go for this sort of message system as a good way of doing this. All right, once there's a bunch of things that we can add to it. So we can take a chat history. So here's like a simple little chat history. And in the sort of templating language, we can basically just go through this. So this is like for message in current chat messages. And you'll see current chat messages, we're going to assign that to be the chat history that we've got there. And it's going to basically just go through, put them in so that we'll sort of set this up. We're going to have the username. We're going to have the character name in there. If we run that through and then we look at the output here, we can see that, the way this is done is we've basically put all these together and it will iterate through those. Now, if we wanted to actually make it so that it goes role user, role assistant, all we would have to do is change this bit up here. And then now we can see that, okay, we're going to get user, role assistant, role user, role assistant, etc. as we go through this. You can take like a chat history or a set of chat messages and basically format them on the fly. Now, the real thing that becomes useful is not just that you're able to do that, but you're then able to truncate old messages. So in this case, I'm going to leave that as user, but what I'm going to do is put in a truncation in here. So you can see that if I go through and we look at the outputs, we've got a whole bunch of outputs in here. But if I basically give it a token limit and I ask it, okay, I don't want the prompt to be too long, it can cut off things. Now, notice it's cutting off from the start and it's not cutting off at the end. It's going to keep the most recent messages in there. And I can actually look at the tokens from TikTok and stuff like that in here as well. But here we can see that we've basically truncated our chat history. And you could imagine that the chat history is 100 times longer than this. And we're actually going to truncate it down to something twice as long as this or something like that. So we could go through and actually do that. Now, obviously, there's a bunch of other things that we want to do as well, is that we don't want to truncate it where we're going to cut off the system message. Now, you can see these templates start to get more complicated as we go along, because you're now putting in a system message, you're putting in the chat history, and you're basically just assembling these parts. We're basically just taking the chat history that we had before. Now, if we actually run through this, we can see that, okay, we've got our system, we've got our, content, etc. there. And then if we truncate it, we've still got our system. So it's cutting off from the chat history, but it's not cutting off from the system, which is a key thing in there. The last one I'll just go through reasonably quickly is that one of the biggest tricks that a lot of people overlook is that often you're going to inject in-context learning examples or exemplars into your prompt. And you don't necessarily want those to be the same. So in this sort of mock example of having like an AI tutor, you could imagine that if it's a tutor about math, we would like to give it math examples. If it's a tutor about Python, we want it to give Python examples. If it's a tutor about logic, we want it to give logic examples, kind of thing. So here, basically, I'll come back and explain this in a second. If we look here, we've basically got a thing where we take in the query of what the user asks, and we look to see, do they mention Python or logic in here? Now, you could use a standard classifier in here. You could use something like a little Distilbert model. You've got a whole bunch of different options of how you could do some sort of classification. All I'm doing here is doing basically a check. Is the word Python in there? Is the word logic in there? So it's really simple example. All right. If the word Python is in there, we're going to fetch some examples of Python code or explaining things in Python. And in this case, you could imagine if the word logic was in there, we're going to select some examples of logic being in there. Let's have a look at what happens. So first off, we've got our system instructions. So it's going to basically give the name of the tutor. We've then got this bit. So Character AI recently has started using audio a lot and having voice conversations. So obviously they have a different prompt when they're using the voice conversations as opposed to when they're using text conversations. So you can see here, this has got a modality. If it's the modality is audio, then it will add in this system instruction that basically the current user is currently using audio. Keep your answers concise and easy to follow. If it's not audio, it won't add that in. So this is a simple thing in their prompt template to be able to add something into the system message or not. Then we've got this whole sort of thing of where we've got these two blocks, one there, which are for the in-context learning examples. And you can see that what this is going to do is basically run this, extract user query topic, passing in the user query. If that returns Python, remember we looked down here that if it's got the word Python in there, it will return Python. If it's got the word logic in there, it will return logic. If it doesn't have either of those, it will just return general. If it's got the word Python, it's going to return Python. And then it's going to go to the Python examples and basically feed those into the system prompt, like we've got here. If it's logic, it's going to feed in the logic ones. And if it's neither of those, it's not going to work for either of these. Then we've got our standard query and our response. So in this case, we've got some simple functions just injecting these in, but you could imagine that these could actually be getting something from a database. There's a whole variety of ways that you could choose the right examples. You could even do things like take an embedding of the query and see, okay, what in-context learning examples are closest to that embedding. So if the person was talking about list comprehensions, like I've got here, it's going to return ones that are about list comprehension, dictionary comprehension, those kind of things. And if it was talking about something else, it could return something different, even though it was still Python in there. Here, though, we're basically just injecting back a list, and it's going to go through the list and basically inject those back in. Let's run this and see, okay, what do we get out? So you can see that, all right, we've injected the tutor name is programming tutor, username student, user query, can you explain list comprehensions in Python? And the modality is text in here. All right, so we can see that you are a knowledgeable AI tutor named programming tutor, right? That's where it got that from. Okay, then we've got our system examples where it has, because it's seen Python in there, it went to the Python one and got that. Now, let's have a look. If I just change this to JavaScript and run it again, you'll see that now those in-context learning examples are not being injected in there. This is with JavaScript. This is with Python. And you can see that, okay, I've got nothing about audio in there. What if I change the modality to be audio? Now you see I've got the user is currently using audio as we go through this. So all of these things can be filled out quite easily based on, how the user is accessing the LLM, whether they're, coming through some kind of speech interface, whether they're texting. And you would even have things like if they're texting over phone and you want to tell the LLM that. So it gives nice short responses rather than long multi-paragraph responses that are not going to be easy to read on the phone. We can then basically take that. If we feed that into OpenAI, you'll see that it has no problem doing this and saying, yeah, sure, list comprehensions in Python provide a concise way to create lists. It gives us a nice answer there. All right, what if we wanted to do the logic tutor? So now we've got logic tutor because perhaps the person has pressed a button that they're asking about logic now. We can take that and we can look at the output here for this. And you can see here, now we've got the logic examples, and I've just put logic example 1, logic example 2 in there. But we can see that, okay, clearly it is no longer getting the Python stuff for the in-context learning. So this is one of the key features of this library, I would say, is that you really want to be able to track the things of where you are in a conversation. It's a much sort of metadata that you can get and pass that in to the prompt to help it out, as well as doing the previous conversation and doing all of that stuff in there as well. So this just gives you a taste of the library. There are a number of other things in there that you could try out and play around with. They've got some nice things for if you're able to do prefix caching and stuff like that. You want to be able to keep that part of the prompt separate. And it just shows you that for something like character AI, where they've got lots of characters going on, they will have lots of prompts going on. And those things are sometimes going to be using things like function calling. So they have a whole system for function calling. But one of the big things that they're most likely using is that they want to save the prompts, right? You want to be able to save prompts and you want to be able to change prompts on the fly. So if you've got your character description, you probably want to have that in one of these template files. Now they call this a template registry, where they're actually saving all of this to disk. And you can see that once it's saved to disk, then they're also able then to basically inject parts to make up the whole. So you could actually inject different parts of system instruction and audio instruction, an ICL gets a character description, all of these things in here. So they do finish up by talking about some of the other libraries that have done some things similar to this. They mentioned LangChain, Llama Index, etc. And they mentioned that those things go beyond a lot further than just prompting for doing things. This is clearly just for managing prompts in here. They also talk about DSPy, which I really should make a video for at some point. It's a very interesting library, which is more about trying to find the best prompt by doing sort of some searches over the prompt area to work out, okay, what is going to be best at getting you the best output for something like a GSM 8K data set, that kind of thing. That is actually something quite different than what Prompt Poet is actually trying to do in here. So anyway, have a play with the library, check it out. It certainly has some nice, interesting ideas of things that To be honest, before manually I hand coded a lot of them. I guess now I need to decide for myself whether I want to stick to my own sort of solution for injecting things into prompts or whether I want to look at moving to this. So anyway, have a play with it. Let me know what you think in the comments. Any questions, etc., put them there. As always, if you found the video useful, please click like and subscribe, and I will talk to you in the next video. Bye for now.